G'day, Bruce here, Barking Dog Bim, and welcome to another edition of Scripting Adventure. In the next few episodes, we're going to delve deeper into the murky waters of doors and windows. It's a convoluted, complicated, and time-consuming process. I avoid them whenever possible, to be frank. But I've got some hints to help you through this minefield when it's your turn. My advice is to not create custom doors and windows unless there's no other option, or it makes the most sense for the project. Stick with custom leaves wherever possible. Also, don't try and create a full suite of doors for your office. It's just far too difficult to create and then also maintain. Instead, just think about them project to project or as specific needs dictate. Generally speaking, you can get away with either the Graphisoft doors or other commercially available doors, such as CI Tools or CAD Swift's Infinite Openings. But there's usually always an exception. Trying to boil all this information down into the most useful parts has proven challenging, and even then it's going to end up being quite complicated. So let's start with some examples first to show you some of the exceptions I've run into over the years and to show you some of the different components required for doors and windows. I've placed all the doors and windows that I've created over the years in this wall here so we can have a look. And they range from fairly simple doors that you encounter in your standard architectural projects to doors that are a little bit more exotic in nature that I created when I was on Avatar 2 and 3, something you would not encounter in your day-to-day. So I'll just run through these. We've got a 2 and 3 leaf door, sliding door, that runs across the face of part of the wall and has door tracks shown. And this was a request by the company I was working for at the time because it was a specific project need that they had that they would encounter often. In the last episode I did on an introduction to doors and windows, I showed that if you're just creating a rectangular window or door, it will automatically cut the holes through the wall for you. However, in this situation, you can see that I've got a niche and then a hole. So that makes use of the wall hole and wall niche commands. So it's only cutting through part of the wall. I've also got arrows that can turn on and off with MVOs under the miscellaneous settings for library parts. Sliding door, none. We'll turn the arrows off. But all the componentry of the door, the frame, the leaves, the glass, the tracks, that's all just standard GDL geometry. And we've got a 3-leaf slider here. We can adjust the transom, mid-span transom. These have got interfaces, and the interfaces have been designed to mimic the Graphisoft door interfaces, so that the user isn't jarred when they open it. It's a familiar environment for them. You can set the number of leaves, number of panes, and the interface responds accordingly. Now, these are meant to have little images here, and I covered this in the series that I did on the interface back in episodes 12 through to 17. When I created these, they referenced the Graphisoft tab icons that were in the libraries at the time, but they have since, of course, changed those names. So that's a good pointer that if you are creating your own interface and you want to piggyback off the Graphisoft icons, make a copy, rename them in a manner that suits you so that they'll always be available for your library parts. Next, we've got a door with a angled top to go under stairs. for example, or where something's impacting the full extent of the door. And we've got the option to open these doors in 3D and 2D. It's always good to have a separate opening angle for 2D, 3D, and I also like to have a separate one for sections and elevations, because in plan, you like to show it one way. In 3D, when you're navigating around or when you're doing renders, you may want to show them a different way, open or closed. But in section and elevation, typically you always want to show them closed. And this makes use of the dashed line in 3D. And for those of you who are at least somewhat familiar with scripting GDL, you will know that dashed lines do not exist in Archicad 3D, which is a shortfall, but is what it is. So this is actually a routine macro that will run and will draw each individual line in 3D with a gap. So it cycles through a loop, draws a gap, draws a line, draws a gap, draws a line. That's how you achieve this dashed line in 3D. Then we've got a more advanced sliding door. And once again, this was made for the office because they would often encounter this type of door on the projects that were frequently executed in the office. You can see it's got a door stiffener here. Now, why would you need to show that? It's just a representation, right? Well, they discovered that people weren't allowing for it in clearances with stuff that would be happening on the balcony. Same with the door tracks here. The reason we're showing the door tracks is because people would not allow for it in their design, in their model, in their documentation. So we scripted these specific doors to tighten up our documentation and make sure we didn't get caught on site. And once again, it's got a familiar styled interface to the Graphisoft doors. And there's various functions available to turn on and off to achieve the results you're after. With this door, because it's got an unusually shaped opening, it again makes use of the wall hole function in GDL to cut the shape as desired through the wall. Then we've got a shopfront opening, concertinaed opening, which you can show at various states of openness. It's got the arrows there. It's got the rebate that these concertinas go into, that the tenant builds their shopfront around to receive that fully open concertina door. And you got various selection options. Make the track mount recessed or surface mount. Change the appearance. Make the panels all the same or change them depending on what the design is. And of course, then you can schedule all this out to send it off to the supplier so that they can fabricate and supply the doors. A roller door, again, written due to a specific need for the office, because we would often encounter the need to document and schedule these sorts of doors, and they weren't available. We couldn't achieve them with the parts that were either on the market or out of the box. So with this one, you can set the extension of the guide above the opening. You can set the offset of the roller from the wall, because sometimes you need to do that because of overhead structure. And we can put in a motor, electric motor, that operates the door, that has the options to place it in any orientation and position as required by the function of the door. And again, included in here to make sure that it's allowed for in the design of your project. It's these sorts of little things that catch you out on site. When you get those frantic calls from the builders, you end up having to work late under a bit of pressure to make sure that you provide the information they need. And this has got different options available to you. Again, with the arrows, Then we've got a face-mounted sliding door, similar to the other sliding doors with a track and the overhead running gear. Then we get onto fancy stuff. So this door and this door are the same object. And by changing some parameters, I can make all the necessary adjustments I need to make one door look like the other. So this has got handles I can turn on and off. Those are controlled by the MVOs as well. So if I turn off handles in here, they respond to that. I can turn on and off the vision panel and adjust its size. For example, I can make it a double leaf. Of course, it's up to me to make sure that my sizes work with the geometry. At least it didn't break. And I can have curved frames. Make it go right down to the floor, so it's got a square frame at the floor, or I could square off the top here. And adjust that as well. Again, responding to a specific project need. These were for the other set that I did. Sliding door. It has the running gear modeled into it so that when you schedule this door, they show up. So for these doors, this is the door schedule that was produced. So this schedule here is straight off the model, indicating which doors are required, and then again complemented with some details so that a fabricator can do what they need to do. Or we can at least start the conversation with the fabricator and ascertain what they need further from us. These doors here were scheduled in this manner. Again, this schedule is straight off the model. Only 2 doors in this set. It was a smaller set. But you can see that the running gear is part of the door so that it can be set out in the schedule itself. This door was fully modeled in GDL, and you can adjust the opening angle. I created hotspots at each of the holes, and you can adjust those. For example, and I put hotspots in the middle of them so that I could dimension them. Now this door here is the same door as this door here and that door there. So what I've got here is I'm using a custom leaf. So if I have a look under my door leaf settings, leaf type is custom, and then I've saved down a custom leaf just by modeling it with slabs and morphs to achieve the level of detail that's required. And then use the custom leaf functionality in my custom door because it was far too difficult to try and script all of this detail in GDL. It's a lot easier just to model the leaf and be done with it that way. Now I've got some heritage windows for a hotel project I did in Sydney. These were existing windows that we needed to model. They all followed a similar design, but they just had different dimensions and some slightly different arrangements. So that could be adjusted. The sunburst could be adjusted. So that window is the same window as that. It's just a different option of arched versus round. I made a square option. Could change the number of sashes to 1. Turn on and off the glazing bars. Change the dimensions of it. Turn on and off the overlight bars. And this is all in response to the existing heritage windows that were in the building. all the different options that were required so that we could have the one object achieve everything we needed. For example, this also had a sill, so the existing building had these timber sills, or either timber or stone, I can't quite remember, which would be on the inside of the windows and with different left and right extensions. So there's a particular transformation you need to execute in order to make sure that the sill always ends up on the inside of the wall, regardless of how you place your window. And this one was in response to, I think there was only one of these windows in the project. Might have been two. But that has various controls that can be adjusted as well. That's right, it had to cater for the new window that we were putting into the project. So there were a few of them actually. So this window was in response to the new windows we had to put into the project to match the existing ones. And of course they were working it out as they went. So the window had to respond to the various design tweaks that would happen along the way, because when design tweaks happen, they want them turned around really quickly. And if you are creating them using the fully modeled custom door, custom window save as geometry, it's a very time consuming process. But if you've got all that functionality already built in to your window, saves a lot of time. Bit of time up front, saves you a lot of time down the track. And you can see that it responds to the MVO, which has separate line types for the inside versus the outside. So it's under here, MVO, line type opening side is dashed. I could change that to solid. Or I could change them both to dashed or so on. And one last one that we had to do was, if I look in plan, so I've been showing you the 3D, but with GDL, you also have the power to make the 2D appear exactly as you want. So you can choose what's showing solid, what's showing dashed. You can choose how it shows up in your plan. You have full control over that when you script your windows yourself. So this last window, this is on the Heritage project as well. We had the Heritage windows in a rather thick masonry wall, and then we lined the inside. It didn't have an inside lining here, but I'm just using that for demonstration purposes. We'd line the inside with a stud wall to achieve modern thermal and acoustic performance requirements. And then we'd have to put in a fabricated reveal, which was a timber cell plasterboard, or what do you guys call it? Drywall. Drywall reveal around it, with responding to either the curved or a square window, with a blind put in it as well, a pelmet put in it. And so I created this object in response to that, which was a project requirement. So just a response to the project needs, so that we could model these as required, quickly and easily, have them show up in our internal elevations, schedule them out, and respond to all the varying requirements around the project. And I did them as a window instead of an object, so that they would attach to the wall. And also, it would automatically turn the skin of the wall in. So that's another functionality you have when you are creating doors and windows, is that you can read the skins of the wall and choose what to do with them. Now I'll point out something here, that when I change my graphic overrides, so to RCP, where I've turned my walls to grey, the skin that I've turned in is grey as well. And you might think, yeah, so what? Well, when you are turning in the skins, you've got to draw that in 2D using 2D GDL commands. If you use your standard Poly2B or Poly2 commands, it won't consider it a wall. you got to use the right GDL commands to make sure that it thinks it's a window that you're drawing, so that will respond to the graphic overrides. And also, when you turn off your doors or windows, so I've turned off my windows, show opening only with contour and RCPs, it will still draw, because MVOs, when you turn off the doors and windows, it won't execute the scripts at all, except when you use the proper commands. So I'll get into that as well. All right, well, that wraps this one up. We'll get into the weeds starting in the next episode. This was just basically an overview of how complicated doors can be. There's more complexity to come, so hold on to your hats. But it should be some good information for you and help you in your journey creating your own custom doors and windows. See you in the next one.